In 2008, Steve Jobs pulled a computer out of a manila envelope. In that moment, the Air wasn't just a product name. It was a challenge to the laws of physics. It told us that power didn't have to be heavy, and performance didn't have to be loud. But for years we've been hitting a wall. The limits of silicon and the physics of heat have kept us anchored to a specific silhouette. We've perfected the aluminum unibody. We've mastered the M-series architecture. But now we are standing on the precipice of something deeper. Today we aren't just looking at an update. We're looking at a total reimagining. As we move beyond the M5 chip, Apple is preparing to shed the last remnants of legacy design. This is the story of how the MacBook Air finally becomes as light as its namesake. The Air philosophy has always been about the disappearance of the machine. With the upcoming M5 chip, we are entering a new paradigm of power efficiency. The M5 isn't just about raw speed, it's about thermal liberation. We expect the M5 to deliver over 4x the peak GPU compute performance for AI compared to previous generations, yet it's being engineered to run cooler at idle than ever before. This efficiency allows Apple to shrink the logic board to the size of a smartphone's, finally freeing the chassis from the constraints of traditional laptop internals. The Air is poised to become the pinnacle of silent, fanless operation, even under sustained creative loads. Strategic material evolution. A lighter, cooler future. To go thinner, Apple must move beyond standard aluminum. Prediction. A pivot toward advanced alloy composites. Imagine a chassis that uses 3D printed recycled titanium, similar to the latest Apple Watch, or a carbon fiber reinforced polymer. These materials offer higher structural rigidity at half the thickness of aluminum. More importantly, they can be engineered with anisotropic thermal conductivity, meaning the case can be designed to pull heat away from the processor and disperse it across the entire bottom surface instantly, keeping the lap and laptop comfortably cool. This isn't just engineering. It's Apple's 2030 sustainability narrative in physical form. A device made of 100% recycled elements that performs better because of its eco-friendly origins. Anticipating the form factor. Compact, minimalist, iconic. What does the future look like? Visualize a MacBook Air that nears the 5.1mm thinness of the iPad Pro. By removing the need for airflow, Apple can eliminate the hollow spaces inside. We anticipate a design that moves away from the classic taper and toward the seamless, rounded curves of the Vision Pro or the sharp, flat edges of the iPad. Without a fan, port placement becomes flexible, and the internal volume is dedicated almost entirely to one thing: battery. A thinner device that lasts 2 full days on a single charge. The future of passive cooling. Redefining Air. How do you keep a pro-level chip cool in a chassis this thin? The secret lies in innovative passive solutions. We expect Apple to employ ultra-thin vapor chambers, sealed units containing a micro amount of liquid that evaporates and condenses to move heat 40 times faster than solid copper. Pair this with graphite heat spreaders and a chassis-integrated heatsink, and the entire laptop becomes a living thermal organ. For decades, the mark of a powerful computer was how much space it took up. The fans, the vents, the heft. It was all a reminder of the struggle between electricity and heat. The next generation MacBook Air deletes that struggle. By fusing revolutionary M-series efficiency with materials that breathe and a chassis that dissipates heat like a living organism, Apple is making the hardware disappear. What's left isn't just a tool. It's an effortless extension of your thoughts.